Welcome back to Applied Algebra and Trigonometry. Let's look further at the law of cosines. I'm going to shrink this just a little bit, keep it up there though as a reference, and we will move on to case 4. So this will be example 2, and let me go back to yellow because that's my example color. So example 2. If you remember from our list, case 4 was when we had all 3 sides of the triangle, and we need to find the angles. So let's imagine that sometime in the hypothetical future I want to build a hypothetical playhouse for my hypothetical grandkids. And hypothetically, let's say I decide to build an asymmetrical roof because I'm going to teach them about green energy and I'm going to put solar panels on this part of it. So let's also say that I have designed this playhouse. My husband's going to help me by bending some flashing for me to put here at the peak of the roof. But I left for a mathematics conference and didn't give him the measurement of that angle. How could he determine what that angle is from the measurements I've given him on the plans? Being a mathematical guy and a logical, detailed thinker, I'm sure that he would start with a chart of what he knows and of what he needs to know. Now, looking at the diagram and the chart, I believe you will quickly see that it is angle A in which we are interested. We also have side A, so the form of the law of cosines that we're going to use will be a squared equals b squared plus c squared, side C, minus 2 times side B times side C times the cosine of angle A. But what we are solving for now is the angle itself. So let's manipulate this formula before we throw a bunch of numbers into it. And if you're going to help with this project, you also need to notice that this entire expression, this one term, is negative. So if we want to make it positive, because who wants to deal with a negative any more than they have to, and the variable we're looking for is inside that expression, let's just move it to the other side by adding it to both sides. Okay, because it is subtracted from the rest of this side, therefore we have to add it to move it to the other side, plus 2bc cosine A. And that will leave us with 2 times side B times side C times the cosine of angle A plus A squared equals B squared plus C squared. All right, we still have to isolate that A, so next we're going to subtract A squared from both sides, leaving us with, and then from this point, because 2 times side B times side C is multiplied by the cosine of angle A, and we are still looking for angle A, we're going to divide both sides by 2bc, leaving us with a rather complicated fraction on the right side, but we're still not done. We still have to free angle A from cosine, so we'll take the inverse cosine of both sides. And finally, we have a version of the formula that we can easily substitute our values into and calculate an answer without a lot of rounding error. So let's move this up to where it's more convenient, and we will substitute our current values into this. We are looking for angle A. So let's fill it in. We want the inverse cosine of, let's see, B is 598 squared plus C is 205 squared minus A, which is 723 squared. Those are all the sides. And on the bottom we have 2 times side B, which is 598, times side C, which is 205. When you are putting this in your calculator, I suggest you add an extra set of parentheses here to make it easier to do your calculations. Also, parentheses around all of the numerator. Actually, a fraction bar does serve as a grouping symbol, or it indicates that there are understood grouping symbols, that the entire numerator is grouped together and the entire denominator is grouped together. And sometimes, as in this case, it helps to actually put those grouping symbols, the parentheses, in there when you're putting it into your calculator. Also remember your final parenthesis. Now, hopefully you remember from geometry that the longest side is always opposite the largest angle, and the smallest side is always opposite the smallest angle, And the mama bear angle is always opposite the mama bear side. Yep, just entertaining myself again. I calculate that A equals 120.1377 blah blah. I need 3 significant digits, so 120, and that is degrees. Notice that for my husband to put the flashing on the roof, he does not need to find the other 2 angles, but let's go ahead and solve the rest of the triangle, just as an exercise. I now have a side and its opposite angle, so I can apply the law of sines. For this problem, it was the largest angle in which we were interested. However, it is always good practice when you have side, side, side to find the largest angle first. Then when you move to the law of sines, you will not have to worry about an ambiguous case where you have to try 2 solutions. So from that point, I just like to keep working from largest down to smallest. So we will do side B next. 598 over the sine of angle B. Cross multiply and solve. Remembering to scroll back up on your calculator to find the unrounded form of 120. And you should come out with 45.7 degrees. And finally, to find angle C, we will do this subtraction. Using the rounded forms, we would get 14.3 degrees. And since your book is not picky about significant digits when dealing with this subtraction to find the final angle, I will not be that picky either. 14.3 is fine. So we have solved the entire triangle, even though my husband would only need to know the angle at which to bend the flashing. And really, once you can do all of this, those are all of the techniques you need to know to use the law of cosines appropriately. Remember, try to just use it once, then go to the law of sines, and then just subtract. Make life easy on yourself. But always remember, if you have side, 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 find the largest angle first. If you have side, angle, side, after you find the first side that you can, go for the smallest angle next. I will see you in our Collaborate session.